Chapter 5, Introduction to Euclid's Geometry. Unit 5.1, Introduction. Geometry began with the practical need to measure shapes. The word geometry means to measure the earth. Geo means the earth and metre means to measure. This branch was studied in various forms in every ancient civilization, be it in Egypt, Babylonia, India, China, Greece, etc. It is believed that the knowledge of geometry passed on from Egyptian to Greece. A Greek mathematician, Thales, is credited with giving the first known proof. This proof was of the statement that a circle is bisected by its diameter. Thales is considered to be the pioneer of geometry. Pythagoras was one of the most popular students of Thales. Pythagoras and his group discovered many geometric properties and developed the theory of geometry to a great extent. In the Indian subcontinent, the excavations of Harappa and Mohenjo-daro show that Indus Valley civilization made extensive use of geometry about 3000 BC. The cities were well planned and organized. Aryabhat, Brahmagupta, Bhaskaracharya contributed to develop the geometry. Geometry was being developed in unorganized matter. Egyptians gave only statements of results. Egyptians and Babylonians used geometry solely for application and practical utility. Greeks laid the basis of deductive reasoning.
Greek mathematician has given the first known proof. Both are Thales. Mathematician laid the basis of deductive reasoning in mathematics. कौन से? Egyptian, Greek, Babylon के Chinese. Most of the contribution to geometry that is useful today was made by dash mathematicians. Indian, Egyptian, Greek के Chinese, Greek.
Unit 5.2, Euclid's definitions, actions and postulates. The perception of the early mathematicians was an abstract of the surroundings. There were just 4 basic concepts back then. These 4 concepts laid foundation for the entire geometry. These 4 basic concepts were solid, surface, lines, and points. To understand Euclid's outlook, let us first get familiarized with these 4 basic concepts. It was considered that solid has a shape, a size, and a position. Further, the boundaries of the solid were called surfaces. Now, the lines were said to be the boundaries of the surfaces. Also, lines were of 2 types, curved lines and straight lines. These lines end in points. Now, keeping these concepts in mind, observe the figure carefully. What do you observe? A three dimensions: length, breadth, and height or breadth. A surface has two: length and breadth. A line has only length. A point has no dimension. Euclid was a teacher of mathematics at Alexandria in Egypt. He collected all known results, compiled them in a series of 13 chapters, each called a book. The compilation was named Elements. Euclid gave 23 definitions in chapter 1 called Book of Elements, a few of which are listed below. 1. A point is that which has no part. 2. A line is breadthless length. 3. The ends of a line are points. 4. 2 points determine a straight line. 5. A surface is that which has length and breadth only. 6. The edges of a surface are lines. 7. A plane is a surface which lies evenly with the straight lines on itself. Now, let us see a few undefined terms. In practice, to represent a point, we mark a dot. If this dot is seen through a magnifying glass, then we think that the dot seen through the glass can be partitioned. But according to definition of point given by Euclid, point has no part. So it is clear that dot is not a point, but it is a model or representation of a point. The same thing happens with the representations of line and plane. Breadth and length are not defined. Hence, point, line and plane are taken as undefined terms, and we represent them using some imaginary physical model. In the geometry that you have learned so far, you may have noticed that these definitions form the basics. In order to learn further concepts, we must be clear on the basics. However, we must note that there are still a few statements and terms which are left undefined. While coming across them, you will notice how obvious they are. This is the very reason that they are left unproved. He divided these assumptions into two types: actions and postulates. A self-evident truth which requires no proof is an action. An action is a universally accepted rule. Let us take a quick look at a few of Euclid's actions. Euclid's actions. 1. Things which are equal to the same thing are equal to one another. 2. If equals are added to equals, the wholes are equal. 3. If equals are subtracted from equals, the remainder is equal. 4. Things which coincide with one another are equal to one another. 5. The whole is greater than the part. 6. Things which are double of the same things are equal to one another. 7. Things which are halves of the same things are equal to one another. If we observe these actions, we will see that they point out to some sort of a magnitude or quantity. In geometry, these magnitudes generally refer to length, breadth, height, area, volume, etc. These common notions refer to magnitudes of same kind. Magnitude of the same kind can be compared and added, but magnitudes of different kinds cannot be compared. For example, a line cannot be added to a triangle. An angle cannot be compared to a square. Note, the fourth action says identical things are equal. Everything is equal to itself. The fifth action gives definition of greater than or less than. If Q is a part of P, then we can write P is equal to Q plus R for some quality R. Thus, P is greater than Q means P is equal to Q plus R for some R. Now that we have learned about actions, let us learn about postulates. We can define postulates as the simple properties which we accept as true Euclid's 5 postulates are as given below. Postulate 1. A straight line may be drawn from any one point to any other point. There is at least one straight line passing through two distinct points. Postulate 2. A terminated line can be produced indefinitely. Postulate 3. A circle can be drawn with any center and any radius. Postulate 4. All right angles are equal to one another. Postulate 5. If a straight line following on two straight lines makes the interior angles on the same side of it taken together less than two right angles, then the two straight lines, if produced infinitely, meet on that side on which the sum of the angles is less than two right angles. Explanation of postulate 5. Let given lines be L and N. A line T falls on the lines L and N and intersects them at A and B respectively. As a result, interior angles, namely angle PAQ and QBR, are formed on one side of the line T, as shown in the figure. Measures of angle PAQ and measure of angle QBR is less than the sum of the measures of two right angles. If line L and M are produced at the side of angle PAQ and angle QBR, then the lines L and M will meet at some point F. About postulate, some statement is made on an observed phenomenon in the universe, and if found true, then it is termed a postulate. A system of actions is consistent if it is not possible to deduce a statement contradicting any action or statements proved based on these actions. deducted 465 propositions in logical chain using its actions, definitions, and postulates. Nowadays, we use the terms postulates and actions in the same sense and are interchangeable. Euclid used his postulates and actions for proving some results. The statements which were proved are called theorems or propositions. Let's define theorem. The mathematical statements which are proved by the use of deductive reasoning are known as theorems or propositions. We have learned the Pythagoras theorem in the earlier grades. Now we will learn one of the most important theorems. Two distinct lines cannot have more than one point in common. We shall prove this theorem by the contradiction method. As shown in the figure, we have two lines L and M. We have to prove that they are only one point in common. In the contradiction method, we assume the exact opposite of what we have to prove. So let us assume that the two distinct lines L and M intersect at two distinct points, say P and Q. Let us recollect an action we learned earlier. Only one line can pass through two distinct points. Hence, our assumption was wrong. Therefore, by this logic, we conclude that two distinct lines can have one and only one point in common. Let us solve an example. D, E and F are 3 points on same line. If E lies between D and F, then we have to prove that DE plus EF is equal to DF. Solution. Look at the figure. Assume that there is a unique line passing through two distinct points. DF coincides with DE plus EF. Hence, DE plus EF is equal to DF. Let us solve one more example. We have to prove that an equilateral triangle can be constructed on any given line segment. Solution. Let a line segment be given of length BC. We can draw a circle with center B and radius BC. Similarly, we can draw a circle with center C and radius BC. Let the two circles intersect at point AB. We can draw the line segment AB and line segment AC. Now, BC is equal to AB since they are the radii of the same circle, and BC is equal to AC since they are the radii of the same circle. Therefore, AB is equal to BC is equal to AC. Therefore, the constructed triangle ABC is an equilateral triangle.
पॉइंट के कितने डायमेंशन होंगे 3 to 1 के नो पॉइंट का कोई डायमेंशन नहीं होता, नो डायमेंशन. The relation AB A plus B is equal to X plus B is equal to B plus B holds true if and only if तीनों इक्वल कब हो गए जब A, H and D सेम होगा तब. देखो connect three points with each other if they do not lie on the same line but lie on the same plane. सेम प्लेस में हो, सेम प्लेन में हो तीन पॉइंट हमारे पास। मानो कि ये हमारा प्लेन है, यहाँ पर हमारे पास तीन अलग अलग पॉइंट है, तो तीनों पॉइंट में से हम कितनी लाइन ड्रॉ कर सकते हैं? 3 लाइन्स। तीनों पॉइंट हो, तीनों पॉइंट को ज्वाइन कर दो तो ट्रायंगल शेप बन जाएगा। यस और नो? ठीक है, तो ट्रायंगल की कितनी साइड्स होती है? 3 साइड्स। दैट मींस वी कैन ड्रॉ 3 लाइन्स। A universally accepted truth which requires no proof is the definition of A or N. Universal accepted truth which requires no proof, that is axiom.
Unit 5.3 Equivalent versions of Euclid's fifth postulate.
इक्विवेलेंट वर्जन हमारे सिलेबस में से कैंसिल हो चुका है। ठीक है, एक्सरसाइज 5.2 वाला